So now we're going to get started with talking about chemical bonding. Honestly, atoms of elements are very, very rarely do they exist alone. Most of the time they will exist in the form of compounds, and that means that the atoms of different elements have to get together with atoms of other elements and bond. And the way they bond is two different ways. One is an ionic bond, which ends up forming ionic compounds, and that's the topic of this video and this whole chapter. Make sure you print out the what you need to know list and follow along with that. And then the other way they bond is through a covalent bond to make molecular compounds. So we're going to write down the definitions of ionic bond and covalent bond, and then we'll go from there. So what is an ionic bond? I have it written here for you guys. It's basically a chemical bond formed through the transfer of one or more electrons from one atom or group of atoms to another. When there's this transfer of electrons, what happens is that one atom ends up becoming negatively charged because it gained electrons. The other atom becomes positively charged because it lost electrons. So once an atom starts having a charge and it's not neutral anymore, it's now called an ion, I-O-N, ion. So this ionic bond that occurs because of that transfer, it's an actual electrostatic attraction between oppositely charged ions. So that's what I wrote over here, okay? When you have an ionic bond between ions, you've created an ionic compound. So basically an ionic compound is a compound that's created when you've got bonding between ions through an ionic bond. The other type of bonding is covalent bonding, and that you will see in the next chapter. Definition of that is basically a chemical bond formed through the sharing of one or more pairs of electrons. You share electrons. There isn't a transfer. You're not creating ions. You're not creating charged atoms. This is sharing pairs of electrons. And we'll get into the details of that in the next chapter. When you have a covalent bond, you create something called a molecular compound, a molecular covalent compound. So the two types of compounds are ionic compounds and covalent molecular compounds. Ionic compounds are stabilized with ionic bonds. Molecular covalent compounds are stabilized with covalent bonds. Okay? All right, in order to talk about bonding, we need to talk about electrons and which ones are the most important electrons involved in bonding. Those are the ones in the outermost shell. So even though last chapter we talked about the location of all the electrons in an atom, in this chapter, we're just going to focus on the valence electrons. The term valence electrons, those are the electrons that are in the outermost shell. Outermost shell. So basically the electrons that are furthest away from the nucleus, outermost shell, the ones that have pretty much the highest energy. They're the ones that are going to be involved in all of the bonding. Okay, so let's take a look at, for example, a fluorine atom. Fluorine's got an electron configuration of 1s2, 2s2, 2p5. All right. Which electrons are in the outermost shell? Not outermost subshell, outermost shell. Second shell is the outermost shell. So how many electrons are considered valence electrons? 2 plus 5. So it has 7 valence electrons. So let's go take a look at chlorine. Chlorine has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p5. Remember how we said that all elements in the same group have end exactly the same way. And you'll see here that chlorine, outermost shell is shell number 3. It also has 7 valence electrons. So what you will find if you do the electron configuration of all the halogens, you will see that they all are in the same group. They all have the same number of valence electrons. So elements in the same group have the same number of valence electrons. And look at something else, which is pretty cool too. Look at the Roman numeral number for all of the halogens. They're all in group 7A, Roman numeral 7A. That Roman numeral for the representative elements, for all those A elements, will tell you how many valence electrons something has. If you take a look at sodium, what is the electron configuration of sodium? 1s2, 2s2, 2p6, 3s1. 3s1. What group is sodium in? It's in group 1A. How many valence electrons does sodium have? 1 valence electron. Why 1 valence electron? Because the third shell is the outermost shell, has 1 electron in it. If you take a look at lithium, lithium is 1s2, 2s1. Okay, 1 valence electron. So everything in the alkali metals, they all have 1 valence electron. So everything in group 1A has 1 valence electron. Even hydrogen, even though it's not an alkali metal, but it is a group 1A element, it has 1 valence electron. So if you are looking at an element in group 5A, it has 5 valence electrons. If you're looking at an element in group 2A, it has 2 valence electrons. Do you get the idea? So you don't actually have to do the whole electron configuration for any of these representative elements. All you have to do is look at your periodic table, your best friend this semester, and look at the Roman numeral. The Roman numeral will tell you how many valence electrons that element has. Okay, so what are we going to do with all that? We're going to do something called Lewis dot symbols that will just represent the valence electrons. I'm going to do Lewis dot symbols. And you just show the valence electrons in the Lewis dot symbol. So if I have a sodium, how many valence electrons did we say that sodium has? 1. So you put 1 dot. Okay. If you've got a calcium, it's in group 2A. How many valence electrons? 2. 2 dots. Okay. If you've got a boron, boron is in group 3A, 3 dots. Okay. Carbon, what group is it in? 4A, 4 dots. Got it? Once you put 1 dot on each one of the sides, just think of an imaginary square, then you can start to double up. And it doesn't really matter where you double up. If you've got a nitrogen, it's in group 5A, 5 dots. So I'm just going to put dot, 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 and then it doesn't really matter where your second dot is. You could have this pair, this here, it doesn't really matter. Oxygen, excuse me, group 6A, 6 dots. Okay, and then finally that fluorine that we just did, we said that fluorine has 7 valence electrons, 7 dots. Okay, so it's single, 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 and then you keep doubling up after that. Now, what if you wanted to do neon? Neon has 8 dots. Okay, 8 dots. All right, you can't go more than 8. Everybody clear on this? So you use this Roman numeral system only when you're dealing with the representative elements. The Roman numeral will tell you how many valence electrons. And it's those valence electrons that are going to be involved in all of the bonding that we're going to be talking about. Okay, so that's a good start. And now I need to drink some water. We will get started with how to create some ions.